Folks, how's it going? This is Mr. Murray coming to you with a Do Now video for Course 2 Honors. This is our video for 320. As you can see here, this video and Do Now is optional, but I strongly recommend you do it, okay? I hope the word optional did not turn you off to it and make you say, well, we don't have to, so I'm not gonna. Because I promise you, if you do take, and I'll tell you this will be less than 10 minutes to do this, it's going to be worth your time, okay? Because as we move on and we begin to put more tools into our tool belt, the trick is going to be to know when to use each tool, okay? And if you're given a problem, how do you know what one I'm supposed to use? Now, we did the law of sines, and then, following that was a law of sines problem, right? Then we would do the law of cosines, and I give you a law of cosines problem. But what if I just presented you with a problem that you could use for any skill? We have to identify which to use. Okay, so this problem is called angle of elevation. So the height of a radio transmission tower is 70 meters, and it casts a shadow of length 30 meters. Draw a right triangle that gives a visual representation of the problem, label the known and unknown quantities, then find the angle of elevation of the sun. All right, so folks, please take a minute. I want you to pause, try to solve the problem, and then when you're ready, unpause, and I'll show you how to solve. All right, so I'm going to go ahead and show you how to solve this one. I highly recommend, if you haven't yet seen my video on angles of elevation, I have a whole video just on angles of elevation and depression problems. I really highly recommend you try. And believe it or not, this was actually drawn from a college pre-calculus book. So if you can do this, you're really in the big leagues. You can see this was number 93, so it's even like a challenging problem within this text, okay? So what do we have? Let's start by identifying our known information. So what we know is that the height of a radio tower is 70 meters. It casts a shadow of 30. We need to draw a right triangle that gives the visual representation and find the angle of elevation, okay? So let's say I do this, right? Well, the first thing you should notice, say I've got my right triangle. I've got a 70-meter tall tower. The shadow is 30 meters, and of course, this is not drawn to scale, so you're going to have to make note of that. And what I want is, I want to know if I'm standing here, this is my eye, looking up, what is the angle of elevation? And I'm going to call that, remember, we call that theta. All right. So in order, when you solve these problems, the first thing you should see is if you can use SOHCAHTOA. If you can use SOHCAHTOA, you're good to go. And you then just proceed. That's the easiest case. The second thing you should do is you should see if you can use law of sines, if SOHCAHTOA doesn't work. Okay. And then the third thing you should do is you should use law of cosines, okay? The reason I'm doing it in this order is, again, based on the personal level of energy that you need to invest. So SOHCAHTOA is the most straightforward way to solve any of these problems, but you need a right triangle. Law of sines is then relatively the second most difficult because of the notion of ratios and such, and because it generally does not involve a right triangle, okay? And then because law of sines doesn't always work, we have law of cosines, which, as you might have seen from the previous videos, is difficult sometimes to get because you've got to do all these numbers, you got to do square rooting and such, but sometimes you need to resort to it. Now, law of cosines in theory could be used. Actually, law of cosines really can't be used to solve this problem because there's not really enough known information. We don't really have that, unfortunately, for this angle. Law of sines, we could use law of sines because we could figure out this length and then use law of sines. But because we have a right triangle, again, what we're going to use is SOHCAHTOA. And so what I need you to do is we have to learn that, one, we may want to start by going in this order. Start with SOHCAHTOA and go to law of cosines. And if you can, use the lowest energy method. But we have to be able to identify when those methods are even possible. So here we want to use SOHCAHTOA. So we know that sine of the angle is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So what we would use here is we would start by noting that the tangent of the angle is equal to its opposite over its adjacent. So that means the angle of elevation is equal to the inverse tangent of essentially 7/3, right? Because it's 70 over 30. So I'll do second tan 7/3. And just to show you that it doesn't matter, I'll show you 70/30 as well. Okay, you can see it makes no difference because 7/3 and 7/30 are equivalent, so it shouldn't matter which one you plug in. Okay, so what we have here, do we see any, nope, we're not asked to provide any kind of guesstimation here. So I'm going to say theta is approximately 66.801 degrees. Okay, please remember that, again, when you're finding an angle, you're using the inverse sign. When you're trying to solve for a side, or inverse tan, when you're trying to solve for the side, you're using the regular tan, right? So sine, cosine, and tangent, sides, sine inverse, cosine inverse, tan inverse, that's when you want the angles. Okay, so our answer is that the angle of elevation is 66 degrees. Notice that if you do 30, because it's awfully close to the special right triangle, it's not quite 70. All right, I thought maybe we would get something like it would be x root 3. Okay, no worries. So folks, thank you again for watching. I hope you found this video to be informational. Please continue to send me any questions you might have. Take today to make sure you're caught up with the lessons that we've done this week. All right, and just stay positive. Keep the good questions coming. And remember, you can do it. All right, thanks for watching. Have a wonderful day. And don't forget to love math.